Good morning, good afternoon, or good evening, depending where you are in the world right now. Today, we've got a very exciting kind of a two-parter. So we've got Sandeep and Yukti, and we're going to be talking about some of the new additions to PMT, as well as some of the new additions to the ColdFusion Builder extension in VS Code. Just want to remind folks there is a Q&A pod. If you have questions as we're going along, please put your questions there. Makes it much easier for us to be able to find them. We do have a chat also. If you just want to chat back and forth, feel free to do that. We've got some links at the bottom right. We've got the Adobe ColdFusion GitHub, which is where all of our code samples will eventually be posted. If you want to be part of the beta, it's happening right now. You can go and join it down there for free and try out all of these new features. And the videos will be recorded and they will be posted to the Adobe ColdFusion YouTube channel, which is also posted there. So without further ado, please help me welcome Sandeep talking about some of the new features coming into the PMT. Thank you, Sandeep.
Yeah, thanks, Mark. I'll take over. Let me start by sharing my screen. Okay, awesome. Hi, everyone. Thanks for joining. I'm Sandeep from the ColdFusion team. Today, I will be talking about how do you monitor your AI services, real-time monitoring for your agents using PMT. If you have been following the webinar series so far, my teammates have covered on different AI APIs that have been introduced in the new update to build different AI services. This is about the monitoring side of it, not how to build AI features, but how to see what's happening inside them once they're running, right? For example, how do you answer something like, how do you know which LLM provider is slow across all the agents that you are, all the LLMs that you are talking to, or which RAG queries are returning low quality results, right? That's what PMT's AI service dashboards gives insights into. So it will give you visibility into every layer of your AI services. So that is what I'll be talking about in today's session. So here is a quick recap on all the AI services that have been covered by my teammates. So starting off with chat models, which is the most basic API to talk to an LLM, right? Then you have guardrails, you have input guardrails, you have output guardrails have a to guardrail your prompts and the responses from the LLM. Then you have function tools. Then you have MCP clients and servers, whether an MCP client within your CF agent talking to an MCP server outside CF or within CF as well. Then chat memory to retain your conversation memory within your agent. Then you have RAG pipeline to create your knowledge base, ingest that into vector stores using an embedding client. You can create embeddings of your knowledge base, embeds of your knowledge base, and insert that into your vector store client. And once you have your RAG ingestion completed, like the knowledge base ingested, you can retrieve knowledge from this and augment it to generate better responses without much hallucinations, right? So all of these have been covered in terms of how do you build such an application using ColdFusion, and then finally the agent itself, where which this orchestrates all of these operations in one single layer, so that it is very seamless to build any chatbot or chat agent, right? So that is the quick recap. Now, what we have introduced in PMT, right? So coming to the agenda, now, given that you have multiple layers to your AI stack, and each of them themselves are independent, and we might want to look into every layer of it, right? So you have multiple tabs that we have created on the PMT side here. One is like for LLMs, right? We have a tab separately for every interaction with different LLM providers. You'll be able to understand the provider distribution across different requests, token usage across providers, average response time for each of those LLM requests that are going out, right? Then the agent itself, which is an orchestration layer for your LLMs, it will also constitute to different tool calls, duration, success failure rate. All of that can be monitored through your PMT service. Then RAG, even though it is part of your agent layer itself, but it itself requires its own tab, because we have ingestion as a one ingestion and retrieval as themselves are significantly larger operations to be monitored, fine tuned, to get better results out of your agent. Then you have MCP clients, where we will cover tool invocations, latency per remote server, then MCP servers, which are hosted as a part of ColdFusion, where either MCP clients from within ColdFusion or outside ColdFusion talking to your server, and you would want to monitor those requests, whether uh, any of those tool calls are resulting in failures, or what is the whether you are adhering to SLS, right, response time SLS of your MCP servers. Then you have vector stores, embedding models. You can monitor your query latencies, model request, embedding model token usage, again response times. Then finally, we have a new view called Trace Viewer to stitch all of this together in one end-to-end span tree for every AI request, so that you have insights into every layer in one screen, one shot, to understand what happened to your given AI request, AI agent request, or in fact any independent call as well. So we will be talking about each of them one after the other, and so what I'll be doing is, like, I have created a demo application to show you this. Like, I've created an playground here, which is Mintu's baby care assistant. This is basically based on my newborn's nickname. I built something that I might actually use at 3 a.m. nowadays, given the new lifestyle change of having a baby, where most of our conversations between me and my wife revolve around what happened with regards to my baby's feed or sleep cycles, right? So I thought, why not build an assistant around this to build this assistant for this webinar. Okay, I'll be using this, and I have a couple of prerequisites. Basically, I have an Olama running for my embedding model, and Olama LLM provider as well, to showcase both local LLM calls as well as the open API or other kind of providers. Then I have MCP servers, couple of MCP servers configured. Then PMT itself, and as well as I have a directory where I have documents to be ingested for RAG knowledge base. So all of these are my prerequisites. Let me go back to my presentation. Uh, right. So we'll start off simple. Chat models, right? This is a simplistic object that we can create, and we can interact with an LLM. So this supports all providers that we have right now. For a given interaction with an LLM, what all things that we actually showcase on PMT, right? How do you monitor this? So obviously, which provider, which model, then followed by token counts and latencies. These are something that we will cover as a part of PMT. So I'll go back to my demo here to present you how this looks like, right? So I have this playground where I can talk to any of these agents right now, right? I'll start off simple, which says, what are the best practices for newborn sleep safety? Explain in 2 to 3 sentences. And if I hit send, this prompt will be sent to LLM, and LLM gives you, it responds you with a reply saying newborns sleep safety includes placing infants on their backs to sleep in a crib, and so on, right? So this interaction, now how would you monitor on the PMT side? So if I go to my LLM tab from within the PMT, so I'll give you a quick introduction. So as you can see, all of these other services that we have supported so far to monitor, right now we have introduced AI services as additional tab to monitor all the AI services that we have introduced as a part of this update. Here, LLM interactions. So this was the interaction, a single interaction, and being the only LLM interaction, we can see this as the slowest LLM call. And if I scroll down further, you also have insights into most frequent models. Then token usage by provider. Right now, I have only single provider use. It used up 124 tokens. Uh, 1 second, let me increase this duration to 5 minutes so that I have a window to explain that data before it goes past. So then you have provider distribution as well as status distribution. It will give you a distribution among success and error states, and then the model distribution, right? So I'll go back to my demo and run all providers. Basically, this runs the same query against all the providers so that we have some data to be visualized on the PMT side. Let's see how it is going to look like once all of these LLMs reply with our prompts. So all of them have responded, and we will go back to the LLMs tab. Here, you can see that we will start getting data. So as you can see, we have more models that are available for us to select in here. So now we have data for all the models. Now for a same query, as you can see, different LLMs have taken different amount of time to process the request, and the number of tokens they consume to reply are different across different models. So this is kind of a comparison view that you can get in terms of if you're doing an A/B testing across LLMs. It will be very easier for us to get that insights into which LLM. Uh, like in terms of relevance, obviously we might have to manually look into, right, with respect to the response. But in terms of latencies and the token consumption, we can get insights from our PMT dashboard. And as you can see, all the charts are populated here with the amount of tokens that have been consumed, the provider distribution. Then you have the model distribution across providers as well as the status distribution. Right now, I don't have any failure scenarios. So we are seeing only failures, sorry, success requests here, right? So that is about the simplest way to monitor your LLM interactions. Now, this chat model being here, if we go back to this slide, chat model being an independent service which will interact with LLMs. Similarly, you have MCP clients talking to different MCP servers. Embedding clients independently can create embeddings as well, and as well as vector stores. You can perform a vector store. You can create a vector store client object and perform search or insertions without an AI agent orchestration, right? So we can do that, and I'm not presenting all of those in the interest of time right now. So we will actually go into the actual use case that we will probably using, right? So I'll go and talk about how can we monitor an agent, right? So what is an agent? In like ColdFusion's own AI orchestration service. So within an agent, there are a lot of layers to it. So now, when user enters a prompt and you submit it to an agent, there are multiple steps it will go through, right? One is you have, let's say, if you configure input guardrails, it will go through the input guardrails and see if there are no, let's say, I don't know, uh, keywords that it is violating, and you would want to block this request, right? And then you have rag configured where it will convert your query and embed it into an embedding vector, then search the vector store for the relevant documents or relevant chunks, and those chunks are inserted into your prompt. Then that particular augmented prompt is sent to chat model, and chat model, it might ask for you to, depending on what function tools are available, it might ask you to execute certain set of function tools or MCP client tools. We will be so then it will enter your tool execution loop, where you will execute those tool calls, and the response from the tool calls are again augmented back into the prompt for chat model to generate again. And this the tool execution loop might execute for a couple of times. I will show you an example. I have examples for everything. So once finally LLM finally stops generating and stops asking for new tool calls, it will exit the loop, tool execution loop, and finally it will go into the output guardrails. And we might, let's say, redact, let's say, PI for use cases like maybe we'll scan LLM responses if it is replying something about our competitor. Those kind of use cases we can capture from the output guardrails. And if it does pass through your output guardrails, finally we will pass the response and update our chat model, chat memory with our current conversation of request and response, and then finally respond back to the user with the final generated response, right? This is a typical high level life cycle of your agent, what happens and in underlying process of your agent. So at every step, we would like to understand what is happening within your agent, right? So this is where, also as you can see, an MCP server being, it can be a remote MCP server that this particular MCP client is talking to, or this MCP server itself could be hosted within ColdFusion by exposing certain set of CFCs as an external external facing MCP server, right? So that is something is a possibility here. And finally, we have PMT to monitor all of these interactions with different external services here. So uh, how do you create an agent? I will not always talk about much about code, but I still want to give you a quick overview on what exactly happened in previous sessions, right? So agent, you can create an agent using configuration like this. We can configure a chat model, and where you can say OpenAI as your provider, GPT-4o Mini as your model. Then you have function tools configured here. These are all the function tools, not MCP tools, because this agent is as simple as it gets. And then you have chat memory configured, which is of type message window chat memory, which is one of the default message chat memory that we provide out of the box. And then you can interact with this particular agent using chat. Now we'll go back to our demo and see what exactly happens. Right, this is basically a baby care agent with tools and memory. Right, I have configured this particular agent, and here I can interact with the agent. Let's say I give this prompt, baby Mintu seems fussy after feeding. Check the feeding routine status and create a P3 care task. Right now, it has responded saying the feeding routine status for baby Mintu indicates that she is fed well and gaining weight steadily, with the last feeding at 2:30 p.m. and next due at 5:30 p.m. Additionally, a care task to check on her fussiness has been created with a priority level of P3 and currently pending. Now, it does say it has done all of this, right? How would you really know if it has done this, right? Uh, I'll switch back to my PMT's dashboard. So here we can see a request which is of from this particular template path and of operation chat, and the duration it took was 6.8 seconds, and the status is success. Now I can click on this view trace. This is where our new trace view has been introduced to understand what exactly happened with regards to this request. So I click on this view trace. So an agent chat in with this particular prompt has resulted into, like, underlying agent. It has interacted with LLM twice. The first LLM interaction, it returned with a finish reason saying tool execution. What it says is, okay, I need to execute these particular tools. Go back and execute those function tools and give me the response from the respective function tools, function or MCP tools, right? So, and in this case, both of them are function tools because it's a simple agent. Here you can see there are two function tools that have been invoked. The first one was create care task, which has this particular input and it has returned with an output. Next is check routine status, right? And it was checking what was the routine status of this particular baby. Both of these function tool responses will be appended or augmented to your prompt in the next LLM call. Here you can see the tool execution result. It says success and the response from that respective tools. will be sent back to the LLM as a prompt, and finally the LLM responded saying the whatever the response that we have seen on the UI. So this is how it will give you insights into what happened to your agent, right? Given that it has a lot of layers to it. So if I go back and let's say ask other set of prompts, right? Check if baby's sleep routine is on track and get the status of care task of particular care task ID. So it did say care task is currently in progress. The last update indicates that appointment has been booked for April 20th, and this task is assigned to Papa with priority level of P2. So although it says all of this, but how do we get insights into that? So if we look at this particular interaction here, as you can see, not this. Right, that was the correct one. So here, as you can see, uh, again, it has resulted in two different function calls. One was check routine status, and the other one was get task status. So this would have returned this particular task ID's response, and it will generate your response back. So this is how an agent, as simple as it is, and you can monitor this agent. And here, if you can see any of these agent interactions, it also has an underlying LLM call, right? So if you go back to your LLM tab, right, you can see, I'll just change the duration to 1 minute to get the recent request. So here, as you can see, uh, it has an entry for slowest LLM calls. And if I click on view trace from this LLM tab, it will still give you and insights into your overall agent trace. So agent request trace. So it will give you the complete trace and which exact request it was part of, right? So that you will have insights into the actual request and the whole face of it. So this way, here you can see there are multiple interactions. As I was mentioning, multiple agent execution tool loop, right? So first chat said it requires a tool execution. We did a tool call. Then we gave the tool response as the tool execution result as the augmented prompt, and even this resulted in another tool execution finish reason. And then again we made another tool call as per the request of LLM. All of this orchestration is being done at agent, right? Agent takes care of what needs to be done. It understands the language of LLMs. It understands the language of function tools, MCP tools, guardrails, and so on. So agent is orchestrating all of this until you get a final finish reason as stop. Once you get a stop finish reason, then that indicates that your workflow has ended and the final response is achieved. So this is how you can trace into your agent, right? Now let me go back. Okay, that is about how would you monitor your agents. Now, what happens when you, let's say, don't fine tune your system prompts, right? How would you identify such use cases? Like, how will these metrics help you fine tune your system prompts? So, in a case, let's say, where you have a system prompt which is more than 500 words, not all of it could be really relevant. You can fine tune your system prompt. I'm not saying this is a simulated example to give you insights on how exactly to debug this on the PMT side, right? To understand that. So, and also I don't have no max tokens constraint, and it is unconstrained, and it might take up lot of tokens as well. So for use cases such that, so if I go back to my demo, I have created a similar same agent, but the temperature is of 1.0, which has very high randomness, right? And max tokens is not configured, and the system prompt, which is of more than 500 words verbose prompt, right? And if I try to interact with my LLM in a way that with vague queries, I think there might be something going on with the baby. May not be. I'm not really sure, but I was wondering if you could help. If we give a vague reason as such, it will take up more token usage than required, and the time it takes could also be on the much higher side, right? So if we go back to PMT, and here if you go back to your LLMs, you will get insights into the number of tokens that it has used, the total tokens used. Uh, Here it is on the higher side, and like not too much too higher in this example, but for the sake of argument here, you will be able to understand such a kind of insights from this particular trace view here, and yeah, and you can also get the similar information from the LLMs tab as well. So yeah, that is about your agent. Now coming to MCPs, right? In terms of cold within the context of cold fusion, MCP, you have both MCP server as well as MCP client. Now I can create and expose any of my existing CFC methods directly as in any of these transport protocols, either HTTP or STDIO, as an MCP server. And when I say handle request, it will start listening to request, and it will uh, like address those requests, right? And I have created one MCP server to handle with these set of tools, where I have search products, check inventory, get order status, and I have configured another MCP agent which uses an MCP client, and the MCP server URL is basically the same MCP server that I have configured as a part of this demo here, right? And here, what you will be able to understand in terms of MCP. So for MCP servers, you would like to monitor what are all the incoming tool requests that you are getting, either from within CF or outside CF, right? And then how much time you are actually taking to return the response for each of those tool call requests. Uh, are you meeting the SLS communicated to your clients? If not, you will be able to go back and fine tune or optimize your tool call requests, right? And similarly, on the client side, every outbound call you are talking to with any of the MCP server and the latency per server. All of these we can monitor on the PMT side. If I go back to my demo here, so here is an agent that I have configured with an MCP server, which is baby supplies MCP server. It has couple of tools: search products, check inventory, get order status. It has three MCP calls. So what I'll do is I'll submit this prompt. Find all newborn baby diapers available in our baby supplier store. Uh, this has, let me check if something is wrong here. Okay. I'm not sure, probably a rendering issue or something. So I submitted the same request again. So here, as you can see, it returned. It says, I found the following newborn diapers available in our store. These are the these are the names of the products, price, size, and stock level, right? So you have all of this information that your agent is responding with. We can go back to our MCP clients here. Let me increase this duration to 5 minutes. So here you can see there were two invocations to your tools. One, like both of them are search products. So each of those tool calls have been like it took 170 or 162 milliseconds in duration, and the status is success. Now, if I view the trace of this, so here, as you can see, this was part of an agent request, agent chat request, where the LLM requested for a tool execution, and you have invoked this tool call with MCP tool call search products. This was the input, and this is the output that you got from this MCP tool. And finally, you augment that MCP tool response into the prompt to get the final response here. So this is how you monitor your MCP client, outbound MCP clients, and you can get insights into most frequent tool calls by server, error distribution by tool. Right now I don't have a scenario for error distribution. I'll, if time does permit, I'll demo that later. uh, and you have server distributions, which is like one on, we have right now only one server, right? And the requests are only in one server, and the tool distribution as well as the status distribution. The similar set of metrics will be also able to look in the MCP server side, because this MCP client is also talking to MCP server hosted by CF itself. So as you can see, you get ART, throughput per server, slowest MCP server calls. You'll see those same set of MCP tools. Additionally, agents also invoke these set of tools, like it will also list tools and initialize your MCPs. So these are also tracked. If let's say as a MCP server, you would like to understand if list tools is also taking more time to invoke. So that kind of insights are also available here. And also similar, like all these charts that you see are very similar to what we have in MCP clients. Okay, so we will go back to our presentation. So that is how you can track all the metrics of your MCP server. If I So next up is right, like how do you identify when an MCP server is slow, right? Like possibly that you have a slow server that you are interacting with, and that is impacting your overall chat responses, because every time an MCP server is like if it takes a lot of time to respond, and your customer waiting on the chatbot for that particular chat response, which is not an ideal experience that you would like to give to your customer, right? How do you identify such a scenarios? So as a part of this demo, I've added a simulated sleeps for each of these tool calls, the exact same tool calls that I used earlier to showcase, and I'll query the exact same queries. Let me run all. So the same set of queries are like fired, like prompts are fired to agent, find all newborn diapers, is product ID current in stock, how many packs do we have, right? And what is the current status of the order? So if we go back to our dashboards of MCP clients, and here earlier, if you remember, like the duration that it took was like 170 or 162 milliseconds, right? Now, if we see, we start getting this information of new server as well, and all the interaction with this new server, which has simulated delay, right? So you can easily identify such kind of servers uh, which are taking more amount of time to respond, and now you will be able to easily debug that. And maybe let's say if the server is hosted by yourself, probably you'll go back and add a cache layer to get a better response time out of this, right? So and like now you can start seeing the server distribution as well as okay, let me change this further up. So here, as you can see, you get good insights into different server distributions and different tool call distribution here, and the status distribution. So this is how you will get insights into your MCP server, right? Next up is okay, RAG ingestion. So now you might want to ingest your knowledge base into vector stores and want to give provide an agent or chatbot which is more knowledgeable in your own domain that you want, right? And it won't necessarily hallucinate by looking at public data. Rather, it will give you a focused search and focused responses. Now, RAG ingestion is something that is also provided, uh, and if you look at the configuration of the code, how it looks like, you will need a vector store for you to ingest your RAG documents here, and then you create an agent where you will say this is the ingestion config, where you will find all the knowledge base at this particular source directory, data directory here, and you can configure document splitter. This is one of the important configuration that you would have to fine tune as per your RAG application, where let's say your chunk size is 300, chunk overlap is 75. You might have to fine tune these configurations to get the best relevant responses from your agent. Then once these chunks are created, where to ingest, right? This is the vector store that you would configure to ingest that information. Now this is the sample agent code that I have to create a RAG agent, and you have two operations on your RAG agent. One is ingest, which is basically a synchronous ingest operation. PMT records this data immediately as and when this operation is done. Then we also have ingest async, which basically will run your ingest operation asynchronously in different worker thread. And PMT, if this async ingestion is in progress, we will show an in progress counter on the dashboard to understand if there are any ongoing ingest operations asynchronously happening behind the scenes. So let me quickly demo this. So if we go back to our knowledge ingestion, so here I have created one operation to create 5 documents about the baby care knowledge, right? So these are again simulated documents for the sake of the demo. And I will now ingest those documents. So this operation will basically ingest those baby care knowledge base, and I will go back to my RAG tab. So here is where you have couple of KPI cards here, where here it is showing one total ingestions, right? So this particular ingestion, if you scroll back to the ingestion pipeline section of this dashboard, where you can see average duration per ingest phase. So ingestion has multiple phases to it. You might want to load the documents, split the documents, transform the documents, and transform the segments, and then finally the ingestion of the segments. Right. So right now I do not have other phases configured, but RAG advanced RAG provides those capabilities for you to configure. So in this case, it had only 3 phases. These are the default phases where you have document loading, document splitting, and the document is split into segments, and those segments are ingested into vector stores. Each segment is first embedded into a vector and then inserted into your vector store. So you have ART for per ingest phase. Then you have this completed ingest operations. So this is where you will get insights into complete ingestion operation, what happened to your ingestion operation. So if you click on view details of this, right, it will give you the complete summary of your operation. So this particular pipeline had 3 phases: document loading, document splitting, segment ingestion. And how much time it took in each of those phases, the number of documents, the number of segments it created, and the number of segments it ingested, and also insights into all the documents that you have ingested, whether a particular document is succeeded or failed. If it fails, it will give you more insights into the failed document as well here. Then you have file type distribution. You will get the insights into if those are text documents, PDF documents, or all the other types of document types we support, right? So this is how you will get complete insights into your document ingestion. And if you quickly go back and start async ingestion, right? And if here you can see this KPI card which says one async job in progress. And if you scroll back to ingest in progress ingest operation, so that itself was not really a huge ingest operation. It has finished quick enough, but so what happens is once the like when the ingest operation, if it is a long running operation, you will see that data here. So maybe I'll trigger once again. So you'll see that ingest operation coming up here and the elapsed time so far. And once it does complete, it will come to the completed ingest operations table, and we will be able to again view the complete life cycle of it. So none of your ingest operations async or sync, like you don't have to worry. You'll be able to track through this PMT what exactly has happened within that particular ingest operation. Although your ingest agent also gives you the complete response to this, but you'll get more insights from the performance monitoring tool here. Now that you have uh, so like this is about the ingestion. Now that you have ingested your documents into a knowledge base, into a vector store, you would want to configure your agent to retrieve those relevant context back before generating an LLM response, right? You would want to augment that relevant context. So RAG retrieval basically is that where You first ingest, and any interaction with your agent, it will first retrieve the relevant content from your knowledge base and then generate it, right? So for this, I'll go back to my demo. So here is an agent where I'm using simple rag here, where it use chunk size 300, chunk overlap 75. Min score of your relevance documents is zero point 0.6, and I'm using a query transformer which is compressing. Basically, it uses an LLM to transform your query into a compressed prompt, so that you'll be able to fetch better relevant documents, right? So we are using the intelligence of LLM to fine tune your search string. Even if user types in a grammatically wrong statement, but LLM decides to better rephrase it so that you will be able to fetch the relevant document. Then we are using default content aggregation. So we'll see how this goes, right? What is the safest sleep position for a newborn baby? So this information, when available within your knowledge base, LLM will be able to retrieve that and reply that, right? So the safest sleep position for a newborn baby is on their back. This is the single most important step to reduce the risk of SIDS. So now we'll go back to our RAG tab, and we will see how this looks like, this particular retrieval operation. So here, as you can see, there were two retrievals that happened within that page here. And even within the retrieval, you have lot of faces, and you will be able to experiment with different types of content injectors, different content aggregators, and routing or query transformation, so that you this will give you insights into fine tune your RAG retrieval as well, depending on the configuration, right? So that is the reason we have face level breakup for each of your retrieval phase. You have ART as well as P95 duration for them. Then the slowest retrieval operations, you can again view the trace of this particular retrieval. If I show you this here, the chat agent, it got a prompt saying what is the safest sleep position for a newborn baby, right? Now, first, what it does is, since we were using a query compressed query transformer, right? So it invokes LLM asking with a predefined prompt to better construct or rephrase your prompt. So LLM has rephrased it to exactly same, because that was already ideal prompt. And this particular string is searched in your vector query. So first it will be embedded to create an embedding, and then we will search that particular vector to find the relevant documents from the vector store. Once you get the response from your vector store as a part of your RAG retrieve operation, RAG retrieve phase, we will augment that back into the user's prompt. Alongside the user's prompt, we will augment that data in the prompt for LLM to finally generate the response. So this is how RAG retrieval can be tracked here, and you can get insights into how much time the RAG retrieval took here, right? And we have one more table where it says retrieval score distribution. We have two things. One is average retrieval score, which will give you the overall retrieval score for all the customer queries. So this will give you insights. If it is very low, that means there is something concerning either with the knowledge base, that it doesn't have the relevant information customers are looking for, so that we might have to create a better knowledge base. Or it could be that customers are uh, entering a very vague, unrelated prompts, or unrelated domain prompts. So even in that case, the average retrieval score will drop, which is something we will be able to understand from the low relevance queries, which is something I'll get to in a moment if time permits. So yes, so here is the relevance score distribution. If this distribution is on the higher side, that means again, as per the average retrieval score as well, your queries are performing better. So, and you also have most frequent documents retrieved. This will also give you insights into the hotspot documents that are mostly referred to or asked questions from. So that will give you the relevance into your documents which are frequently retrieved. Uh, right. Let me go back to a scenario for your retrieval. Let's say you have very poor configurations which you are not aware of, right? And you might have given a chunk size of 2000 and there was no chunk overlap, which is very bad for your retrieval. Like there are very huge chunks now created, and none of your prompts when queried against the vector store, it doesn't retrieve any documents from this, right? And even if you are allowing min score of zero point 0.1, like even weak matches still reach the LLM. If you have such a kind of a configuration, how would you identify on the PMT side? Like how would you fine tune again, right? So I have a simulation for this. So here, as you can see, I have configured a RAG which has chunk size of 2000 and a chunk overlap of 0 and min score of 0 zero point 0 in this case. Like I'm accepting any possible match right now, right? So I will run all the queries in one shot. What is the safest sleep position for a newborn baby? So this was the same query that we fired in the previous demo as well. Here it says some relevant information it is still giving you back, right? So if you see this particular prompt, what are the essential items I need for newborn baby? It says I cannot find that information in the available documents. It didn't that our knowledge base did not have such a kind of information to address such a kind of a prompt. If we go back to our uh, RAG tab, here you can see the overall average score, average retrieval score has dropped from earlier zero point 0.8 to 0.65 because of your poor configuration of RAG. And we start seeing retrieval score distribution, which is on the lower side. Like you can see 0.3 to 0.5 has 8 retrievals and 0.5 to 0.7 has 12 retrievals, which tells you that you either like user is giving a vague prompt or you have a configuration which is not ideal or not the optimal one, right? And also it gives you insights into low relevance queries. This particular query has returned with a relevance score of 0.47. Right now we can will be able to pinpoint from which template path and line number this agent call was made from, right? To understand what happened to this low relevant queries, if you click on this, it will give us take you back to your existing URL view. This is the URL view, and we had enhanced some features here with regards to AI services as well here. So from that particular page, we'll be able to navigate to our AI services page, and we'll be able to get the trace view of your operation here as well. So even here, you'll be able to understand what happened to your request and what was the prompt which resulted in a low relevance query, right? Now you can go back and look into how do you better ingest your knowledge base or better create your knowledge base or better chunk or better configure your agent. So those kind of insights we can get from this particular RAG dashboard. Now I'm not talked about vector stores. So since all the underlying operations of a RAG retrieval or ingestion happen through vector stores and embedding models, we do have a separate tab for that to understand ART throughput per vector store and ART and throughput for embedding models. So all of that information is also available here. So here you can track the slowest vector queries, top five slowest vector queries. Won't add all took more time. All the others, given that I'm using an in-memory vector store, these times are very low. But ideally, when you have a real production use case, we'll be able to see a lot of data here. Similarly, for slowest embedding calls, I'm using local Olama running on my system here, which where I'm using this all mini LM embedding model. So you can get insights into vector query errors, embedding errors, vector store distribution, embedding provider distribution, embedding token usage by model, status distribution. All of those details you'll be able to get from vector stores. So yeah, that is about your RAG retrieval and how would you configure that. I do have a full production agent that I have created, which has which constitutes of all the things that we have talked about. We have function tools, we have MCP client tools configured, you have input guardrail configured, chat memory configured, then your ingestion configurations for ingesting your documents, like knowledge base into vector store, and then your retrieval augmenter that will help retrieve the relevant documents, right? So this is one full blown agent where if you see, I have this setup step I have created where it creates some into scarebot which is ready now, which has ingested 5 baby care documents. It has these tools configured, baby care desk tools. These are basically function tools. Then you have an MCP, which is baby supplies client, which is different, and it has other set of tools supported. Then you have input safety guardrail. Then you have multi-turn memory, which uses chat memory within that, right? I will execute all of these queries in one shot to show all the data that is getting populated. So we should start seeing data across all the tabs right now. So give it a couple of seconds. If we go back, we'll see what happened. Okay, it has executed all of these queries one after the other, all of these prompts one after the other. Right now, if we go back to our uh, dashboard. So we start seeing all the chat operations that have been performed on these ingestions. So then we'll be able to see all this information in one shot, and you'll have information with regards to LLMs, vector stores, right? Then we have RAG, all the retrievals, ingestions that have been performed. Let me increase this time window to 5 minutes. So we have one ingestion, 5 retrievals, average retrieval score, docs processed. If there are any failures or if there are any async jobs running, we'll be able to track it here. And ingestion pipeline, just operation completed ingest operations, in progress ingest operations. Right now there are no ingest in progress ingest operations. So this gives you a full blown view of what is happening to your agent, and at different layers, all the building blocks of your agent, you'll be able to understand the latencies, token costs, right, failures, all of them in one shot in your PMT. So finally, I do have one use case where it generates all the use case, all data across all the tabs again, and it does include some error cases as well. Before this completes, I have one more tab to talk. Okay, how do you enable this? Now that we have this configure these features on the PMT side, how do you enable this? This is the most important part. I thought I'll keep it at the end so that it sticks with everyone, right? So we have couple of different flags that to enable monitoring for AI, and we have some granular flags as well to control more in terms of what data is stored, how much data is stored, right? So we have one master toggle, which is AI services monitoring, to by default collect all the AI related metrics. This is by default off. It's by default off, but you have to opt in, and it will enable all the AI services monitoring. Then you have another flag under AI services monitoring, which will save inputs and responses. Now, why we need this flag? Given that if you are storing all the inputs, input prompts and LLM responses, the amount of storage it takes to save on the Elasticsearch, which is the underlying backend for underlying persistent store for our PMT, that data size can blow up, right? And you won't be able to understand. So maybe for a brief moment, you might want to monitor your traffic. You can enable this, understand how your traffic pattern is, and understand the types of queries users are giving to better fine tune your agent, and you can turn it off, right? That is one flag that we are supporting, and we also do have maximum saved text length. So by default it is capped at 5,000, but you can fine tune up to your use case depending on how much space it is going to take, or how much info it is going to give you, right? Then we have minimum relevance score. This is something I'll showcase on the PMT side, right? Let me go back to configuration of the PMT. So this is where under the given nodes monitoring configuration of advanced monitoring, we have this new flag called AI services monitoring. This is the global flag. You disable this, everything is disabled. Once you enable it as an opt-in feature, you can choose to save AI inputs and responses for tracking. If you do choose to save that, you have to decide on the maximum saved text length. So this is like these are all the nested fields that you have. Then we have track RAG data processing performance. So why do we have a separate flag for RAG? Because as you can see the dashboards itself, if you are saving let's say 10 GB of all the knowledge base, right? And if you are uh, monitoring, if you enable monitoring for all of those, right, then what happens is it will blow up your Elasticsearch storage, because it will eventually, let's say if you're ingesting 10 GB of files, obviously it will invoke a lot of vector store calls and embedding calls, and the data that is required to monitor all of these within a rack context, it will blow up your space, right? So to control that, whether or not you want to monitor RAG, we have a flag here, then followed by a minimum relevance score. So this minimum relevance score is basically to this will basically power. I'll show you. I'll make this zero and show you this. So this will power this low relevance queries table. So this will basically depending on what is the threshold that you configure. If it is below the threshold, right, you will be able to see those relevance queries. Now depending on your application, you can decide whether zero point 0.6 is low for you or zero point 0.8 is low for you. And if you are targeting for high relevance knowledge base, right, if you keep as high as zero point 0.9, everything below that comes up as the low relevance queries, and you will be able to understand why they are of low relevance by this particular table. So that is how you can control this particular table's result set through that particular configuration, right? So now let's go back to so we have all of these edge cases running, right? Let me see if there were any failures here. So as you can see here, there were some failure status requests as well. So here what happened? So your input guardrail has blocked it in this case, right? And then this retrieve phase did not complete for quite a while. This doesn't give good insights. Uh, Let me run a failure scenario. Okay, I'm almost out of time. I thought I'll cover some set of other things as well for error scenarios as well. But yeah, that is it about PMT for AI services within ColdFusion. How would you monitor all of your services? I hope you guys got a good understanding on how to monitor your AI services by this session. Let me know if you have any questions right now, or I'll be sticking around. You can always add your questions to your Q&A section, so I'll be able to answer them. Uh, yeah, so after this, my colleague Yukti, she'll be presenting a VS Code extension features of all the new features of VS Code extension. So I hope she'll take over after this. Let me know, guys, if you have any questions in the Q&A section. Thank you so much.
Hello everyone. So I hope my screen is visible and everyone is able to see my presentation.
Yep, we can see you.
Okay. So hello and welcome everyone in today's session. Today I, Yukti Agarwal, will be presenting you about how to increase productivity with CFB extension. So without further ado, let's set the agenda for today. Firstly, we'll discuss about CFB extension, a quick overview. Then we'll see what all enhancements we have done in this release along with the demo. And at last, we'll take up Q&A. So what is CFB extension? CFB extension is basically fast and lighter version of CF Builder, which we earlier used to have. In this case, this extension is supported in VS Code, due to which it makes us easier to use and also in additionally provides us with a lot of modern capabilities that comes along with VS Code. And not just that, in CFB extension, we have also provided a large number of CF specific features, and some of them I have also listed here, like project manager, server manager, editor features, integrated debugging, and security analyzer. So now let's move ahead and see what all we have introduced in this release. Before that, I would like to specify what intention we had in mind this time. It was basically to increase the scope of CFB extension so that it can further increase productivity of our CFML developers. Keeping this in mind, we have majorly worked on these following areas, that is performance platform support, Docker support, syntax coloring, code assist, and security analysis. So let's start with platform support and we'll go one by one and discuss in detail about each of them. So with platform support, we are glad to announce, in addition to Windows and Mac, we have now officially certified Linux as well. So now you can all leverage all the features that comes with CFB extension in your Linux machines. And secondly, it is hassle free without any workaround. You just need to ensure that user have correct permission to access it, whether it's write or execute and so on, like depending on your use case, and you are good to go, right? So moving forward, next is Docker support. So similar to how we allow managing local server and remote server, we are also now capable of managing servers which are running within Docker. And uh, this basically eliminates the container barrier which comes with Docker. And not just that, we with this enhancement, we will now be able to manage and debug all the CF applications running within that container. So basically it provides us with a simplified development experience without much of a workaround that user might be doing, creating a different development and then testing or like on deploying it further. So basically to reduce error related to all this hassle, right? So we can say that with both this platform support and Docker support, now we have made our extension more versatile. So you don't need to worry about like which environment to work on. You just simply need to think about what application you need to develop. So now with said that, we'll look at our first demo related to Docker. So basically, in this demo we'll look at three things. Firstly, how to configure Docker server. Secondly, how to manage project, and thirdly, how we can debug it. Right. So let's switch our screen. So firstly, we'll configure our Docker server. So let me tell you, I have already deployed the deployed server in the Docker container. That only I'll be adding it here, right? So is hosted on 8501 port. Then we'll select is remote and Docker. This is like what you need to specifically remember, that we need to first select is remote radio button, and then we have to use this Docker checkbox. Then moving to next, we'll specify web document root of Docker. Then we'll add the mapping. Mapping is basically mapping our local directory with one present inside Docker. Just a second. So this is our Docker project. So now we are good to go, and we can see that it is green. Then secondly, we'll add the project. The project which I created within that is order service, so I'll just use that name only. Applications, Docker project, order service, then project. So we'll select Docker as a server, 2025 as a dictionary, and so now we can see that we already have some of the files within that. What we'll try to do, we'll try to execute this file and see its output level, like how what it is giving and whether it is able to run or not. So you can see we got some of the output, and it is running on same port which we mentioned. So we can say that it is correctly working well with Docker server. Then maybe we can try add some more output, maybe 4 or maybe good evening. So you can see good evening is now appended. So we can be assured that yeah, we can properly develop within our within same VS Code extension without like copy pasting by changing here and then pasting it inside the container. So that is one thing. Now let's move to third part, that is debugging our application. What if we run into some issue, then how we will debug it? So for that, we have some prerequisite that we need to keep in mind. So one thing I'll show you before going to the administrator. Mm, Docker. So if you see this file, I have this is basic Docker compose file, and here I have opened 3 ports. So this is the main thing which you need to remember. First port is for administrator, second port is for line debugging, and third port is for connecting debugger with VS Code. So for that, similarly, after we have opened this port, we need to similarly mention it in our CF administrator. So let's launch our CF administrator. Password was administrator. So I've done quite few settings already, like I have enabled this RDS service. Then inside this debugger, I have added this allow line debugging. Then within this Java and JVM, we need to specify those ports in JVM arguments. So this here for line debugging, this gets automatically added, right? So what we need to add is this debugger port that is mentioned, which that is the third port which we specify, which we opened while building the Docker while deploying the container. So this is the important thing which you need to remember, right? So and after that, after we submit the changes, we just need to restart, and then we are good to go. Okay, so this was like the basic thing which we need to do. So now I have set the breakpoint here. What we'll do, we'll just simply press run and debug as ColdFusion. Okay. So yeah, this is correct error. So earlier while configuring, we did not provide any RDS username or password. So as we all know, why for debugging it is required. So although I enabled it there, but we also need to specify this connection, and when we have tested, it is working fine. So we have saved the changes. Now let's try it again. So it's working. Let's see. So now we can see our break flow our flow has come to this breakpoint, and now we'll try to debug it using step into. Then there is one more component. So here also it is going seamlessly. And now if we see, so we have got correct output. So now we saw like how easy it was to basically add a configure server, or like adding project, executing it, or be it debugging. So this is like similarly how we used to do for either for remote server or local server. It is nothing different you need to do. Just remember that debugger server port flag you need to add to JVM, and apart from that, everything else is same. Also, we can verify one more thing, like when we enabled RDS. So here we can see that we are able to view all the files in that remote server. Then secondly, here also we see, but since we don't have any data sources added, so it is properly showing no data sources added, right? So this was about Docker. So let's move forward with our next section, that is syntax coloring. So as we all know, syntax coloring is also an important part, or we can say important feature, as it helps to improve our developer experience, as by clearly providing different colors to keywords, variables, functions, identifier, etc. And on top of that, it also provides or flags if there is any syntactical error within our code. So this makes it more useful, so that on the go we know, like, okay, this syntax we have missed, or like it is incorrect. So this time what we did was to basically rebuild our CFML grammar and made it context aware. So what and how it helps is that earlier we were using default JS grammar which VS Code provides, but it was not CFML context aware. So uh, it used to basically now we can more correctly distinguish between CFML and uh, other language codes, like be it HTML, CSS, or JavaScript. So as a result of this, now we are able to we are not getting any unrequired errors, or maybe also as a result it also resolved various critical issues, and which we can also view from these screenshots. I've added a few here. So like we see in this screenshot, although this is valid syntax, like in this is valid JavaScript, but what issue was there, we when we added this single hash, all the parsing started failing, right? And similarly we see another issue. So in this we can see that when we use CFML within JavaScript, so it is unable to properly distinguish that, so therefore giving the error and breaking the parsing for rest of the file. So now if we see other images, this is what we get now. It is looking better and not flagging any of the unwanted errors. And similarly in previous screenshot as well, now here also we can see it is properly parsing the file and providing color syntax uniformly and required as expected, right? So now we can say, yeah, we won't be encountering all these kind of syntax coloring issue, and thus making a better experience while coding. So now moving to our another important feature, that is code assist. As we Why we say it is important, because it basically smooths smooths our writing process of writing code. So in this also, like we have one of the thing is we have added full dictionary support for all the new built-in and member functions, be it AI services, cloud services, or Mongo services. But not just that, this time we have stepped up to improve our code assist for uh, providing support in various other critical areas, like if we talk about AI service. So AI service have struct type parameters and that have a larger number of keys. So we we can't expect like to remember either all those keys or like referring documents each and every time. Wouldn't be better like if we have all the suggestions on the go, we know like okay, all these keys are supported, so that there are less chances of writing incorrect code. And then not just that, apart in addition to this, for cloud services, if we say, so we know there are different types of services like Firestore, S3 storage, and all those things. And all those services have different types of members function. So now with this release, with this enhancement, we will be getting specific type this service specific member functions. And also we did not stop here only, we also provided proactive proactive deprecation warnings, like on the go. If you are writing some of the deprecated code, you will be it will be flagged right there only, and with a simple strike through, right? And if you hover over it, then you will properly see like what all remediable or like what all actionable item you can do to fix that. So I have added some screenshots here, but with that said, let's move to our demo demo for this code assist. So basically, we'll in this also we have divided into three parts. Like firstly, we'll see how struct parameters code assist for struct parameters work. Then service specific suggestions for cloud services, and then we'll see this deprecation warnings. Okay, so let's stop this. AI feature. So as we already saw, like there are a lot of AI features which we have introduced. So here also in VS Code, we have provided uh, various service support for various services. Like if we see for MCP, there are three built-in function: client, server exists. Then there is some for vector store. So we have provided like complete support. But today we'll be looking at one of the service, that is chat model. So let's define variable and chat model. This is not that. So here if we see, chat model has a config parameter which is of type struct. So now if we want to populate it with all with required keys, then we'll just, or want to know what all keys are supported, we'll just press control space, then we'll get some suggestion, we'll press enter. So now you can see it is populated with all the required keys, although it supports large number of keys, but for simplicity and keeping the code clean, we have just populated it with only required keys. Now if we see for provider also, we have different types of options. Okay, so now suppose if we select Anthropic and provide model name as Claude Sonnet 4.6, and now we see this, we can see a lot of options. So also with this options also, we can, if we press control space, we will be able to see what exactly that key is about, right? If we see for API version, then max tries, max token, so all these keys. So let's try. Okay, maybe this response format. So response format also had options. So maybe we select JSON. So all this kind of thing. Other now let's try with some other type of provider. Let's create chat model obj2. Then again defining chat model, same procedure. Now let's this time select OpenAI, right? And in this we maybe select GPT 4. Right. So now here also we are getting similar approach. Take it like this time. But one thing which I want to highlight, like we have created two different chat model objects with one with type Anthropic and one with Open. So depending on this provider type, also we have different types of keys supported. So one of the keys which we can see is like for this, there is one key stop sequences, right? So this is supported here, matlab, for this Anthropic provider type, but for OpenAI it is not supported. So therefore we won't get that uh, suggestion as well, right? But there is another key which OpenAI supports, like this is seed, right? But here this Anthropic does not support, right? So no suggestion is coming. That is like that is not a correct. These are not suggestions. It is just placeholder values, right? So we can see how sorry. So we can see how we have optimized this. Like we are providing all the keys with all the required help text, or maybe also optimized it to provide only those keys which are supported, valid for that provider type. Now let's see another service, that is I'll create one agent object. So there we'll see nested struct and other functionality. So here also we select this config. So now if we see here, we can since we have already defined chat model, so we are getting variable option to select that object. Maybe we can select this, right? Then there are further more options. Suppose if we select this chat memory, right, it is also of struct type. So here, since it is of struct type, we are getting further suggestion to populate it with specified struct. So here for chat memory, it was struct, but it did not have any required values. So it was not auto-populated, but we can select any of whatever it is, what is required by us, right? And similarly, we see another parameters, that is input guardrails. So it is of matlab, it is also of supports array of structs. So in that case also it falls in same category, that there also, if we have struct, so now for that how we will know key. So that thing also it is supported. We just need to click okay. And here in this, the only key which is supported is CFC. So since, and here we can provide this multiple structs as well, right? So this is how we do it, right? So all in all, with this example we got to know like what all features are supported, and how exactly this struct parameter kind of thing works. So maybe now let's move on to our the second part, that is cloud service. So for cloud service also, so like there is one application.cfc which I've created already. So here in this I've defined two variables, that is cred and config. And config, it is service is of type Firestore. So if we see, let's just comment this one first. So get cloud service. Here we'll you specify application cloud. Then here we'll specify the application config. Now since we have specified the service name, so if you see, what is, one second, there is some parsing issue. We'll just So basic get cloud service, get cloud get. So now you can see, since there is no parsing error, so our code assist is working fine, and all the member functions related to Firestore are coming correctly. Suppose if we select this collection, then with respect to collection, say next level of member functions will come. Suppose if we select here, maybe limit to last. So you got my point. Like, it is basically we can, depending on the service type, or our member function list get filtered out, and we get only required suggestions. Now we can also verify this by changing the type of service name. Maybe we use S3. So now we see. So you see how quickly, or like optimized in optimized way, it is now only showing member functions related to related to S3. So similarly, if we want, we can try that member chaining thing here as well. So in this way it works correct, right? So now, since enable requester pay return struct type, so now we are getting struct type of suggestions. So this was quite related about cloud service. Next, let's move forward and see the deprecation thing. So although I have added it here, but let's take an example of this create object itself. Basically, deprecation warning is for both function and tags. Whenever we are using deprecated function tags, this strike through line will be there. For example, like this create object only. We will suppose use this create object of this Java type. You can see that it was valid, and we are not getting any any error or warning. If we change it to Corva, so instantly you got this strike through, and also you got this why the issue was coming. Like ColdFusion 2021 release has modified the usage of system function create object, and Corva value of type or parameter has been removed. Similarly, we have provide the remedy key. We have to check the type of the object. And similar, now if we again change this to Java, that is valid, so this strike through option does not come. So all in all, we can say with all these three things, your code assist related experience would definitely enhance. Now let's move forward with our slide and see the last bit, that is security analyzer. So secure, as we all know, security analyzer is also a very important feature, as it, while development only, it helps us to flag out all the security vulnerabilities which are existing in our code. So this time we say, recognizing its importance, we have revamped it, and we have worked on different areas. Like, we have improved its performance so that it is able to handle or process large project, or if large number of information is coming from the server, or also we have introduced new security rules, be it related to XML or cryptography or file injection, like major other important things as well, right? These are some of the rules which I have listed. Then apart from that, there are other two things. Firstly, we have provided widely used format, that is PDF, support of PDF and CSV. So you can easily export your this analysis security analysis report, and in whatever format or desired format, whichever you like. And also to increase, like, your experience for uh, going through this analyzer, we have also improved this, made it better. UI, we say, you can see this from screenshot as also. Like, we have all this graphs, all these charts along with different filters, and now it looks visually appealing and also easy to interpret this data and understand it better. So this was kind of a quick overview, but it has a lot to discuss. So today we, because of time crunch, we cannot do that, but do will be available to tune in tomorrow's session, which is presented by Megha. She will be diving deep into security analyzer, what all features we are providing, and how all functionalities will be working. So before moving to Q&A, I would like to say that uh, in addition to all the major features which we have discussed, we have further also fixed various issues, or like various other enhancements which we have done. So maybe once we release this, you can go ahead and try this, so that we and also basically it will be improving your experience further than previously, and also try to give us feedback so that we can proactively work on it. So now let's move ahead and open our Q&A. Let us know if there are any questions regarding this.
So I think there was a question earlier on about the PMT. CF Dynamics asked, are there automatic cleanup for log information that is stored, like the input and responses, so that they are only saved for 30 or 90 days, for example? I think this was Sandeep. If Sandeep wants to jump in and talk about if there's any automatic cleanup stuff. Sandeep, are you there?
Am I audible now?
Yeah, I can hear you now.
Okay. So just we do not have currently support selective cleanup for input and output, but on the what we support is the existing data cleanup scheduler, where we can clean up the whole index, but we do not have a selective cleanup for input and response information. That if you do persist, we do not have a selective cleanup for that yet. Looks like a valid and good feature to support. We'll look into that.
Awesome. Yeah, Sharvi is here, so that's potentially an interesting feature addition to do, maybe filtered cleanup for particular things which are noisy after a certain time, because I know like logs will often get so big that they can cause some problems with the PMT. So that might be an interesting way to do that.
I think
Awesome.
the concern would be more around if it does have PII information or things like that. If you would want to clean up, I think that makes more sense.
Yeah, that's a nice one too. Yeah, like being able to filter that out and clean up PII and HIPAA concern, things like that. Awesome. Were there any other questions from anyone? Oh, I didn't see anything in the chat. Well, if you do have questions, feel free to email us, to post it in the CFML Slack, or on LinkedIn. We're all over the place. I want to thank Andy and Yukti for an amazing set of talks today. Very, very cool new features. I really like, this is actually my first time seeing some of the PMT stuff, and it's amazing. This is like so exciting. Like, this is such a full-featured addition to the PMT, and it aligns perfectly with everything that we're adding in AI. I want to thank you all for joining us today. Make sure that you come back out tomorrow, April 22nd at 10 a.m. Pacific time. Megha and Rochelle are going to be talking about security. So lots and lots of changes there, lots of additions, lots of cool new stuff, lots of fixes. It's going to be a great session, and I hope to see you all there as well. I'm going to go ahead and stop the recording.